For my capstone project, I worked on a topic which was predicting the type of cyberbullying in tweets. The aim of this project was to build a predictive model by comparing the accuracies of a machine learning model, which was a random forest deep learning algorithms, the CNN, LSTM, and also a pre-trained organ-based transformer to classify tweets into the cyberbullying classes. Cyberbullying is something that is very sensitive, especially in this generation of social media. According to the CSE.edu, 20% of minorities who are cyberbullied consider suicide, while 10% actually attempt to take their own lives. This has caused about 4,500 deaths per year. And cyberbullying, according to tech targets, is the use of cell phones, instant messaging, emails, chat rooms, or social media networks such as Twitter to harass, threaten, or intimidate someone. This is actually a growing problem, and for this reason, I wanted to analyze how we could predict this type of cyberbullying in tweets. The data was primarily sourced from Kaggle, and before cleaning the data, there was over 47,000 records, and after cleaning, there were about 47,349 records. I noticed that the data set was balanced, and by being balanced, this means that there was almost equal entries for all of these classes. And the classes that I worked on was the not cyberbullying, gender, religion, other cyberbullying, age, and ethnicity. I sourced external data to perform some EDA, and the use of this external data, for instance, there was a profanity list which contains common curse words used in tweets. And the reason why I did this was because I noticed that, for instance, if someone was to write ASS on tweets, they might use the pound sign instead to replace the S's. And when I did punctuation removal, it was kind of difficult to get the word. So that was why I sourced external data to be able to match it and extract those profanity words. The profanity words were used majorly for data analysis and data exploration. So after summing the curse words in the tweets, I observed that ethnicity class had the highest curse words, and not cyberbullying had the lowest curse words. In the middle, this is a word cloud of common curse words that were used in the tweets. On the right-hand side is the average number of words per cyberbullying. The religion class had the highest number of words used per tweet. For modeling, I looked into four models, and this was because I wanted to address the models from the simplest one to a more complex model. The metric used in this project was the accuracy, because the data set was almost balanced for each of the classes. The training score for the random forest was about 78%, and the test score was 79%. So for training, I did k-fold evaluation or k-fold evaluation such that the data set used to train, the model was able to see the training data set and it was also able to predict on the validation data sets. And the random forest was actually a simple model. I moved into, or I used a complex model, which was the convolution neural network. The training score was 85% and the test score was 84%. I could not use k-fold evaluation in this model because of the time it took to train. So I had to stop using it, and I just set epochs instead of using the k-fold evaluation. To address overfitting in the CNN model, I used dropouts, and I set dropouts to values like 0.2. This was to ensure that the model wasn't overfitting. For the bidirectional LSTM, which is also a more complex model, the training score was 85% and the test score was 83%. I also didn't do k-fold evaluation or k-fold splitting on this model. It was also a very complex model, and I also set dropouts to address overfitting. For the pre-trained Hugging Face transformer, I could not record the training score, and this was because I did not exactly enter the parameters, the training parameters or the log parameters to save the training score. And because of the long and amount of time it took to train, I could not rerun it because it was really a long time. So the test score, however, when evaluated on the test set was 84.9%. I also could not perform k-fold evaluation on this. When it came to data splitting, the training data set was splitted such that it contained 70% of the data set. The test and validation data set as well were splitted as 15% and 15% each. Now to the results and findings. I'll be comparing the confusion matrix for the Hugging Face transformer and the confusion matrix for the CNN model. The Hugging Face transformer actually, for instance, in cases where the record was labeled ethnicity, it was able to predict it 1,227 times correctly. And also for cases where the label was labeled ethnicity in the CNN, it was able to classify it 1,225 times correctly. On the right-hand side is the training loss curve, train validation loss curve for the bidirectional LSTM and the CNN. So the models, the train validation loss for the CNN shows that the model actually fitted well and there wasn't much overfitting in it. And so does the BI-LSTM, the training loss validation. Although there is a point where there is an intersection between the training loss and the validation loss. So in future work, more parameters should be used to fine-tune the Hugging Face model, because when I was training the model, I used just the default metrics. Also, k-fold splitting should be done on the CNN model and the bidirectional LSTM. And future work should include the training and loss curve for all of the models. Thank you for listening.